Well, it's about time. You know, it's been almost 2 full years since we released our How to Install ESXi 7 video. Now that VMware has officially released ESXi 8, it's time we release our updated video as well. So if you're looking to get started with ESXi 8, stick around. This video will be a step-by-step tutorial, starting with downloading and installing ESXi 8, then configuration and walkthrough of ESXi via the management web UI, and then finally building your first VM on your new host. If you're looking for something specific, check the chapters below to jump to the part you need. If this is your first time working with ESXi, I highly recommend you run through this video from beginning to end. Sound good? Let's get to it. To run ESXi on a host, you need to meet the following minimum requirements. Officially speaking, for Intel, anything 6th generation and above is supported. And for AMD, Zen 2 and above is also supported. I say officially supported because you can force ESXi 8 to install and function on unsupported CPUs, which is totally fine for a home lab or test environment if you don't have more modern hardware lying around. ESXi 8 needs a minimum of 8 GB of RAM, but you need more like 12 to really effectively run any VMs on it. You'll need at least one compatible 1 gig network interface. For your install disk, you'll need at least a 32 GB disk for the ESXi Hypervisor to live on. And like older versions of ESXi, it cannot be a USB stick. And of course, you'll need at least one disk for storing your virtual machines on. This can be an NVMe, SSD, or even a mechanical SATA disk. Alright, assuming you've got the necessary hardware, let's go get ourselves a copy of ESXi 8. Open up your browser of choice and head over to vmware.com/go/get-free-ESXi. You're going to need an account with VMware to download ESXi 8 and get your forever key. If you don't have an account, creating one is easy and free, and they don't continually spam you. Click the Create Account link and run through that process. We'll wait. For those of you who already have an account, click the I have an account link and log in. Since we already have an account, that's what we'll do. Once logged in, we'll need to register to get our copy of ESXi 8, so we'll swing down and click Register below. And yes, we'll have to fill out yet another form and scroll to the bottom and click Start Free Trial. Don't worry, you're not getting a trial copy of ESXi 8 here, trust me. Back on the eval page, you now see your forever key for ESXi, as well as a link to download the ESXi Hypervisor install ISO. First things first, copy your key and save it. We'll need it after we get ESXi installed. Now we'll click the manually download button and get our copy of the ESXi installation ISO. Save that too, we'll need it here in a second. Alright, now we need to create our bootable USB stick to install ESXi on our host. To do this, we'll be using our tried and true favorite ISO to USB software called Rufus to create the boot stick. You can download Rufus free of charge from rufus.ie. It's an indispensable tool, so keep it around in your IT bag of tools. Anyway, this is Rufus. We'll be using an 8 gig USB stick, which we've already inserted and see listed at the top. All we need to do is click Select to select our downloaded ISO image, navigate to our freshly downloaded VMware ESXi ISO file, select it, and click Open. Now we click Start at the bottom and click OK to the warning about the destroying of the contents of the USB stick, and wait for the process to complete. Depending on the USB stick you chose and the write speed of that stick, this can take a bit, so let it finish. And done. Okay. Pull that stick, it's time to install ESXi on your new host. You can install ESXi on practically any supported hardware you like. Your home lab doesn't have to be running on server iron like we do here at the channel. This little Lenovo ThinkCenter here is a perfect option with this 8th gen Intel i7 CPU, a 500 gig NVMe for boot, and a 1 TB mechanical disk for additional storage. Whatever you choose, I recommend that you try to have at least an SSD in the system for VM storage for the best performance for your VMs. On our little host here, we'll be using the NVMe for VM storage as well as the install target for the Hypervisor, which is a completely supported method of running ESXi. The mechanical disk will be used for storing files like ISOs and other data we'll use for the VMs. Anyway, let's get this install started. Alright, I'm going to assume you've inserted the bootable USB stick we made just a bit ago and that you know how to configure your host to boot off that stick. I'd love to tell you how to do that, but different hardware takes different steps, so refer to your motherboard manual or Google searches to figure out how if you don't already know. When you successfully boot off the USB stick, you should see the ESXi installer loading screen start up and begin booting. The boot process can take a bit depending on your USB stick's read speed, your host, and the interface you're using. Give it a bit and let it start up. Welcome to the VMware ESXi 8.0.0 installation. VMware would really like you to know that they only support running ESXi on supported hardware and would love for you to go check out their compatibility guide. It is genuinely useful to check it out when you're planning to add new hardware to your host, but for right now, we'll just hit Enter to continue. Ah yes, what installation wouldn't be complete without a mile-long EULA to agree to? Thankfully, you don't have to scroll to the bottom to accept this, so let's just do what everyone else does and pretend we read it. Let's hit F11 to get to the next screen. The ESXi installer will now scan your hardware for installation targets for the OS and present them for you to choose from. Like I mentioned earlier, I have 2 disks in this host, one 500GB NVMe, which will run dual duty as my ESXi install target and my datastore for VMs, and an additional 1TB mechanical SATA disk for additional storage. You might have a ton of disks in your host, and it can be hard to know which one is which, so you can always select a disk and press F1 to get detailed information on the selected disk. Anyway, we're going to target the NVMe disk as the new home for our ESXi 8 install, so we'll hit enter to continue. Of course, the installer wants you to be aware that this action will wipe out any existing data on your install target, just in case you didn't know that would happen, so let's hit enter again to continue. Now we need to choose our keyboard layout. I'm in the US, so obviously I'm going to choose the US default, but if you're in another part of the world, use the arrow keys to scroll to find the layout that best fits you. Let's hit enter to continue. Alright, it is password time. For those of you new to ESXi or Linux Unix OSs in general, root is the administrator user. The root user has all the rights and privileges, and in the case of VMware ESXi, is the only user on the host out of the box. And because this account has the highest level of privileges, you should choose a password that's secure. Go ahead and enter that password now and then again to confirm. If you see a message that says passwords match, then we're in business. Let's hit enter to continue. And just when you think you've confirmed enough, you get one last chance to back out. Not us, we are ready to do this. Hit F11 and let's get this party started. Installation can take a bit, so let it do its thing. Feel free to grab a cup of coffee and wait. Let's get going, shall we? Congratulations, you've just installed ESXi 8. Now let's reboot this host and do some basic but very necessary configurations before we hit the web interface. Alright, here we go, booting our fresh install of ESXi 8. Yes, it does look very similar to the initial part of the install process, thanks for noticing. Let me be the first to say welcome to the console of ESXi 8. If you are not a fan of gray and yellow, you will be by the end of this.
You will be. You will be.
Anyway, this is all you'll ever see on the video output from your host from now on, and you'll rarely ever need to visit here. We do, however, need to make a few quick changes to the management interface of our host. By default, our host grabbed a DHCP address, and while that's cool and all, it's not the right way to do this. We need to give our host a static address because that's best practice. We'll hit F2, and then we'll enter in the super secret root password we set during the installation. After you've entered in the password, hit enter. Okay, we're going to make a few quick changes to our host's management network, so arrow down to Configure Management Network and hit enter. There's a lot you can do in this configuration menu. You can add, change, or remove network adapters from your management interface of your host, set a VLAN ID for your management network if you're running a managed VLAN, and of course, make changes to your IP addresses and DNS configurations, which we'll be doing right now. Arrow down to IPv4 configuration and hit enter. As I said, by default, the host uses DHCP, which is fine, but I highly recommend you set a static IP address for your virtual host. DHCP is for clients, not servers, so don't be lazy. Let's arrow down to Set Static IP Address and Network Configuration and press the spacebar to select it. Then arrow down and set your IP address for your host. We'll use 192.168.0.21, but your network will likely be different. Once set, hit enter to continue. Alright, we need to set up DNS for your host, so let's arrow down to DNS Configuration and hit enter. Once again, we'll use the arrow keys to select Use the following DNS server addresses and hostname and press spacebar to select it. And then at a minimum, set a hostname for your host. Your DNS servers will likely be correct because they were obtained via DHCP. We're going to name our box ESXi 8 because we're original like that. You can name yours anything you want. Once you've chosen a hostname for your host, hit enter. If you have more than one DNS suffix on your network, you can add the additional suffixes using the custom DNS suffixes config. We don't, so we'll move on. All done here, so we'll hit escape. Now we're asked if we want to apply the changes that we've made to our management network. We'll hit Y, and those changes become a reality. Back to the system's configuration screen, we're basically done here. I will, however, show you one useful thing that you can use to verify your network changes were correct. Arrow down to Test Management Network and hit enter. Alright, here you can run a quick ping connectivity test to make sure your host's management network is configured correctly and ready to rock. By default, the addresses that were automatically added here are your DNS servers, network gateway, and the host's new hostname. Those are all great targets by default. However, you need to have created a DNS-A record for the new hostname for it to properly resolve. We're going to throw some different addresses in here to test if our host can get out to the internet and resolve hostnames. We'll leave the first two addresses as is because they are our internal DNS servers. We'll add 8.8.8.8 to address number 2, which is Google's public DNS server on the internet, and change the hostname to google.com to verify that we can resolve hostnames properly with DNS. You can use any addresses you'd like. All that matters here is that when you hit enter, you get back OKs for each. If you don't, check your network configuration before continuing. We'll hit enter to continue and escape back to the ESXi console screen. All done here, friends. Let's pop a browser from our desktop and continue our setup of ESXi, shall we? Okay, back to our browser of choice. Head up to your address bar and enter in the IP address of your host and hit enter. You're going to be greeted with a "Your connection is not private" message because your ESXi host is currently using a self-signed SSL certificate. Rest assured, your connection is in fact private, so click Advanced and then click the Proceed link below. Thanks, Google. Assuming all is well, you should be greeted by the ESXi host client login web interface. For those of you coming from ESXi 7, you'll notice that VMware has spruced up the place a bit. Once again, we'll enter root as the username, and then your super secret password that you're getting so good at entering. Once you've done that, click Login. Welcome, friends, to the ESXi host client web UI. Pretty cool, huh? Let's take a tour and get familiar with the UI. On initial login, we land at the host summary page. On the left-hand side of the screen is the navigation menu that we'll go through here in a bit. In the main window, we see summary details of our virtual host, including a hardware summary, configuration information, system information, and a performance graph summary from the last hour. Up at the top right of the main window, we have a capacity overview of the host, including how much CPU, RAM, and storage are being currently utilized. And down at the bottom of the screen, we have a recent tasks pane that gives you a live list of currently running and completed tasks on your host. Let's pop over to Management in the Navigator pane. Under the System tab, our first stop is on Advanced Settings. Here you can make changes to a variety of different advanced settings on your ESXi host. I'm going to be honest with you here, unless you're trying to solve a problem or experimenting for fun, it's very unlikely that you'll be making changes here. Next up is the AutoStart tab. AutoStart is where you configure VMs to start up with the host. By default, when you create VMs, those VMs will not start when you power up the host. For VMs you want to power up when the host powers up, you'd come here and select the VMs you want to AutoStart, set their priority, and so on. Useful stuff. Now on to the Swap tab. This allows you to define where the swap file for your VMs will exist. By default, you don't need to make any changes here, but if you wanted to keep your VM swap file within the VM's data store, you could make that config change here. Time and date is critical for your host and our first stop to make a configuration change. Accurate date and time is necessary for a healthy host. Valid timestamps are crucial for troubleshooting logs, and the correct time is necessary for all varieties of authentication and authorization. We'll be configuring NTP on our new host, so let's head up to Edit NTP Settings. Alright, let's set our host to use NTP by clicking the radio button next to Use Network Time Protocol. And then we'll change the NTP service startup policy from Start and Stop manually to Start and Stop with host. If you miss changing this setting, your host will not synchronize time. Lastly, we'll need to provide a few public NTP servers for our host to synchronize with. The 3 IP addresses we'll be entering here are NIST NTP servers in the United States. You can use the same NTP servers we're using here or any NTP servers you'd like, just separate the IP addresses with a comma. Once you've entered in your preferred NTP server addresses, click Save. You'll notice that the NTP service is not started yet. Don't worry, we'll get there shortly. Moving on, let's click Hardware at the top. Our first stop is the PCI Devices tab. Here you see all of the hardware that ESXi has detected within your host. If you wanted to pass through hardware to a VM, this is the location where you'd go to do it. Next tab is the Power Management tab. This tab is where you can make changes to the power management policies of your virtual host. Once again, it's very unlikely you'd be making any changes here. Next stop is Licensing. Out of the box, fresh installs of ESXi operate on a 60-day evaluation license. This evaluation license has every licensable feature enabled. If you wanted to play with ESXi and vCenter with all the bells and whistles enabled, you can do that for 60 days. We're going to go ahead and apply the license key we received from VMware when we registered our copy on the website. That license is very basic, but is perpetual, and there are no limits to the amount of VMs you can run on your host. We'll click Assign License at the top, paste in the license key we copied from the VMware website, click Check License, and then Assign License. Just that simple, moving on. Next tab is the Packages tab. This section provides you a list of all the installed drivers and packages that are installed as part of the default installation of ESXi. Alright, on to the Services tab. These services or daemons serve various functions for the ESXi host, and for the most part, you won't need to make changes here. We will, however, be starting the NTP client service to get our host synchronizing time from the NTP service we just set up under Date and Time. We'll locate the NTP daemon, highlight it, and click the Start button on the top to get the service started. It'll take a moment to start up and synchronize time. You won't need to do this again. If you remember from earlier, we set the NTP service to start with the host, so on the next reboot, the host will automatically start the NTP daemon. All good, moving on. The last tab under Manage is Security and Users. Our first stop is acceptance level. VMware prides itself on building a stable and robust hypervisor. As a way to protect a host from untrusted or unsafe packages and drivers from being installed, VMware defines different trust levels. By default, the host is set to allow installations of trusted packages and drivers from trusted partners. These are signed packages from trusted partners VMware has vetted to ensure stability for your hypervisor. There are 3 other levels: VMware Certified, which are packages certified by VMware; VMware Accepted, which are packages that are not certified but receive blessing and oversight from VMware; and lastly, the community level, which is the Wild West of unsigned and untrusted packages. Authentication is next. If you have a Microsoft Active Directory server functioning and you want to join your ESXi to ADS for authentication, here's where you do it. Joining a domain is relatively easy to do, assuming you have the rights in ADS to do so. Moving on. Next stop is certificates. When we installed ESXi, one of the functions it performed as part of the installation was to generate a self-signed certificate for use on the host. That's the certificate details we see shown here. If you want to install a new certificate on your ESXi host and make the Google Chrome gods happy, here's where you would do it. This is assuming you have a PKI or public key infrastructure set up somewhere to generate your trusted certificates. Under Users, we find our one and only user root listed. This is pretty self-explanatory, but for simplicity's sake, if you want to create users that had specific roles for managing, say, VMs or data stores, here's where you'd create them. Now on to roles. ESXi uses RBAC, or a role-based access control concept, where users are added to groups or roles that grant the rights and privileges you'd want them to have to do certain tasks. Lastly, but not least, is Lockdown Mode. Put simply, Lockdown Mode essentially allows you to lock down your host so that no changes can be made to its configuration. This is a standard means of hardening the host to protect it from accidental or malicious changes as well. Lockdown mode can have user exceptions as well, which are useful if you want to deploy your host in a lockdown mode but want a break glass admin account to use in case something needs changing or something goes wrong. That's it for the management side of the web UI of ESXi. Let's take a look at monitoring. Back to the navigation pane, let's head over to monitoring on the left. Monitoring your host is obviously a very important part of managing your host. On the first tab, Performance, we can graph out the utilization of different hardware aspects of our virtual host. This includes CPU utilization, memory utilization, network bandwidth usage, and of course, disk throughput as well. If you're having performance issues with your virtual machines, these graphs can give you a great 10,000-foot view of what's going on with your box. Next tab is Hardware and System Sensors. Depending on the hardware you installed ESXi on, you may have a lot of information here, or, like me, none at all. Server hardware usually has dedicated baseboard management controllers and IPMI capabilities that monitor all aspects of the system. My little Lenovo ThinkCenter doesn't have any of those capabilities, so there's nothing here. Below System Sensors is Storage Monitoring. Again, you may see information here and you may not, depending on the hardware you've installed in your host and whether your system is server class or just a desktop. Moving on. Next tab is the Events tab, where you'll find events that have occurred on your host. It's important to note that an event can be anything from a user logging in, to a server starting, to a system issue. Anything can be an event, so it's a great place to check for troubleshooting as well. Now on to tasks. Tasks are actions that were executed on behalf of a user on your host. When you create a VM or start and stop one, those actions are tasks that are executed against the virtual host. Tasks are also where you'd see the success or failure of configuration changes you've made. This is also a great place to check if you're looking to remember if or when you shut down, rebooted, or otherwise changed a VM, as a time-stamped entry will be listed here. And as you can imagine, it's where the recent tasks that were listed below can be found after they've fallen off the list. The Log tab allows you to view different logs on the host directly from the web UI. Back in my day, we had to use SSH to log into the host to view the logs, and now they're right here with a handy-dandy search to boot. Right on. And lastly, the Notification tab. Notifications are messages that you received when you logged into the host. Those messages can be dismissed or ignored from view on the host summary page and then will end up here. As you can see, I have some notifications that I've ignored, and they'll be here for me to deal with at a later date. Alright, let's dig into virtual machines, storage, virtual networks, and finally, build our first VM on our new host. In the Navigator, the virtual machine section is where you can create, delete, and interact with all VMs that are on the virtual host. Obviously, we don't have any VMs on the host since it's brand new, so we'll come back to this section in a bit. Moving on to storage. Storage is where you'll find all the provisioned storage on your virtual host. When we built this host and installed ESXi 8 on the 500 gig NVMe, the install partitioned a section of the hard disk for the Hypervisor install and made the rest of the space available for virtual machine storage as a datastore named datastore 1. For reference, VMware uses the term datastore to describe a storage device that is used for storing virtual machine files and other data. If you remember, I also have a 1 terabyte hard disk in this host that doesn't appear here in the list because it hasn't been provisioned yet. Let's walk through how to provision storage on your ESXi host. First things first, let's click the New Datastore button on top to start the wizard. Our options here are to either create a new VMFS datastore. VMFS, by the way, is the file system used by ESXi for storing data. Add an extent to an existing VMFS datastore. Expand an existing VMFS datastore extent. Or mount an NFS share. We're going to create a new datastore, so we'll stick with the first option, but just as a side note, if you have a NAS that can serve up NFS, you can use that NFS share as the datastore for VMs as well. Anyway, let's head down and click Next. Next step, we'll need to choose the physical disk, which is the target for our datastore. You can see in the list below, my 1 terabyte disk is listed. Before we can continue, we obviously need to give our new datastore a name. You can always rename a disk later without breaking anything, so don't feel like you have to make the best choice right now. Anything descriptive about the disk, its performance, or its type will do. We'll name this disk SATA HDD because, well, that's what it is, and click Next. Here you can decide how you want to partition out your disk. We want to use the full disk for VM storage, so we'll leave it on Use Full Disk, but if you had a need to break up the disk differently, you could. VMFS 6 is the most recent iteration of the VMFS file system, and that's what we'll leave it set to. Let's move on by clicking Next. Last stop is just a simple summary of the changes we're about to make to the disk, including the name, the target device, the partitioning scheme, and the version of VMFS we'll be formatting in. All good, let's click Finish to complete the provisioning. Of course, we're going to be asked one more time if we're absolutely sure if we want to format and provision this disk, so let's click Yes. And now we see the new datastore named SATA HDD listed below. The name of the new datastore clashes with the default datastore name provisioned when we installed, so let's rename that while we're here to match. It's super easy. We'll just select the datastore, head up to Actions at the top, and select Rename. To keep in line with our previous naming convention, we'll name this one NVMe SSD, and click Save. Now they match. How nice. Networking is our last stop in the navigator. By default, we land on the Port Group tab. Port groups are a way to configure a network settings that are then assigned to a virtual machine. Let's say your network has multiple VLANs configured and you need those VLANs to be accessible to certain VMs. You would create a specific port group that sets a specific VLAN for any machines assigned to it, and then any VM added to that port group would have their network traffic tagged for a specific VLAN. The concept might feel complicated now, but you'll get the hang of it, I promise. The good news is you have a default port group called VM Network that you can use right now to get your VMs out on your network. The next tab is the Virtual Switch tab. A vSwitch or virtual switch is simply a virtual representation of a physical network switch, but exists virtually as software on your host. A vSwitch has physical uplinks that connect to the rest of your network just like a physical switch has uplinks to other network gear on your physical network. You can assign port groups to vSwitches and then use those uplinks to get out to your network. There are other types of virtual switches like DV switches or distributed virtual switches, but they require vCenter to leverage. Physical NICs are just what it says. These are the physical network interfaces within your ESXi host. In the list, we get an at-a-glance view of the vNIC name, the driver being used to control the device, its MAC address, its auto-negotiation configuration, and its current link speed if connected. We have just one here built into our host, but you can easily imagine a virtual host in a data center with multiple high-speed network interfaces connecting out to all manners of physical networks. Next tab is the VM kernel NICs tab. VM kernel NICs are virtual network interfaces that serve different purposes in ESXi. For example, a VM kernel NIC is a virtual interface that can be used for management of the host, can be provisioned for iSCSI attached storage, vMotion, and more. On a build like ours, we're only going to have one VM kernel NIC, and it'll be assigned to the management network for host management duties. Next stop is the TCP/IP stacks tab. These are different TCP stacks that are built for special purposes like vMotion, provisioning, and so on. You're not going to be utilizing this section much at all in a single host environment, so we'll move on. Last stop is the Firewall Rules tab. Your ESXi host has a built-in firewall that has rules configured by default to keep your host safe and only allow certain traffic in and out of the management interface. Keep in mind, the firewall in ESXi is not a firewall that protects or filters your virtual machine's network traffic, only the virtual host's management interface. You still need to have firewalls on your VMs to protect them. Okay, if you've stuck around all the way to this part of the video, it's time to build your first VM. Let's get rolling. We're going to build an Ubuntu 22.04 desktop VM, so naturally we need to have a copy of the Ubuntu 22.04 desktop ISO to build it. I've already downloaded a copy, but before I can use that ISO to build my Linux VM, I need to upload that ISO to my host so I can mount it to my VM as a CD. So let's jump over to storage in the navigator on the left. I have two data stores, one being the ultra-fast NVMe with a smaller amount of storage, and the other one being the 1TB mechanical hard disk. I'm going to place the install ISO on the SATA data store because it's slower, has more space, and will be a great storage place for ISOs. So I'll select the SATA HDD data store on the right, and then click the Datastore Browser button on the top. The Datastore Browser is exactly what you think it is, a simple file manager to browse the files and folders on a particular data store. Right now, there's nothing on the SATA HDD except for a hidden folder used by ESXi. We're going to create a folder to hold our ISOs for easy management, so we'll click the Create Directory button above, give it the name ISOs, and click Create Directory. Now we have our new ISO folder listed in the root of the SATA HDD data store. Our next stop is to upload the Ubuntu 2204 desktop ISO I downloaded. So I'll click the new ISOs folder, and then click the Upload button at the top. I will now navigate to and choose my Ubuntu ISO and click Open. On the top right of the Datastore browser window, you can see a progress bar showing the upload in progress, and also in the background in the Recent Tasks pane as well. Great, now that that's done, we can see the ISO listed in the ISOs directory. All is well here, so we'll click Close. Alright, let's get our Linux VM built. Let's head up to Virtual Machines in the Navigator pane on the left. And now at the top, we'll click Create Register VM. This wizard will help us through the process of creating a VM. The first option, the one we'll be using, Create a New Virtual Machine, is for creating a fresh new VM by hand. The second option, Deploy a Virtual Machine from an OVF or OVA file, is what you'd use if you downloaded a VM from the internet that was packaged as an OVF or OVA format, which is a standardized means of packaging up a VM to be shared. And last is Register an Existing Virtual Machine, which is a way of adding a VM to your host's inventory if the VM files already exist on a data store but aren't registered on your host. Anyway, let's get down and click Next to continue. Our next stop is to give our new VM a name. We'll name ours Ubuntu 2204. Compatibility defines which generation of ESXi this VM will be compatible with. Typically speaking, if you're building VMs for your own host, go with the newest version supported, so version 8 for us. If you're planning on building VMs on your host and exporting them as OVF templates to share with others, you might consider an older version for backwards compatibility with older VMware hypervisors. We'll leave ours set to 8 and move on. Next is Guest OS Family. For the best compatibility for our VM we're building, we need to tell ESXi what host we'll be running in our VM. We'll be building a Linux VM, so we'll select Linux. Next stop is to define the distribution and version of the OS we'll be running in our VM. As you can see, the list for Linux is very long. We'll scroll down and find Ubuntu 64-bit. Last stop on this page is to click Next. Alright, time to choose the data store that we want to hold our virtual machines files. Generally speaking, the faster and better performance storage you use, the faster and better performance you'll get from your VM. Makes sense, right? We'll land this VM on the NVMe SSD, and then we'll click Next. Now comes the fun stuff. Under Customized Settings, we get to define all the virtual machine hardware we want to provide to our VM. This includes the amount of virtual CPUs, RAM, size of the hard disk, USB controllers, network interfaces, CD images, and more. There are a ton of additional options within most of the hardware choices. For example, if you need to define things like cores versus sockets, resource shares, or prioritization, you can do it. We'll avoid a deep dive for now. We do, however, need to add the Ubuntu Linux ISO we uploaded to act as a CD for the VM. So under CD/DVD drive 1, we'll click the down arrow and select Datastore ISO. Now we're greeted with the familiar Datastore browser, so we'll navigate over to the SATA HDD data store, and then our fresh ISOs directory, click the Ubuntu ISO image we uploaded, and then click Select. Now we click Next and we land on the final page, which is the summary page of our soon-to-be-created Linux VM as we've configured it. All looks good, so we'll hit Finish to get this party started. And there it is, our freshly created Linux VM. Let's check it out. Alright, this is the summary page of our new Ubuntu VM. You'll see basic configuration and summary details about the VM, including the hardware config and current resource consumption. Right now, our VM is off, so the only resource it's consuming is storage for its virtual disks. Let's boot our VM and check it out. You can use the power button at the top, or you can click the play button in the console window. And there we go, our first VM is up and running and booting off the ISO we've attached. Just like that. Great job! Now that you've finished watching this video, check out our playlist over here of other great virtualization videos we've made in the past. If you're interested in getting into VMware or virtualization, we can help you out.